Hello guys, welcome back to another AIME problem solution video. Today we've got another question here, and as always, to start off by first reading the question. A special deck of cards contains 49 cards, each labeled with a number from 1 to 7 and colored with one of 7 colors. Each number color combination appears on exactly one card. Sharon will select a set of 8 cards from the deck at random. Given that she gets at least one card of each color and at least one card with each number, the probability that Sharon can discard one of her cards and still have at least one card of each color and at least one card with each number on it is P over Q, where P and Q are relatively prime positive integers. Find P plus Q. Now to start off, let's write it out without loss of generality and assume that the 8 numbers in Sharon's cards are going to be 1, 1, 2, 3, 4, 5, 6, and 7, and that her colors are going to be color A, color B, color C, color D, E, and F. Now from here, you can see that in order for her to be able to remove one of the cards, we're going to have to find out we're going to find the probability, we're going to have to find the total number of ways to assign these colors to numbers and versus the total number of ways that actually works. Now, the total number of ways to assign the 2 reds to any of these numbers is going to be 8 choose 2. So I'll write total here. 8 choose 2 minus 1. Now, the reason why we're only considering the configurations of the 2 A's here instead of the entirety, so like A, B, C, D, E, and F here, is because 1, it's going to be way too hard to calculate, and number 2, it is unnecessary. As you can see here, total number of ways that actually works depends on the two colors that are repeating and the 2 numbers that are repeated. So in other words, we just don't need to calculate and consider all the configurations based on B, C, D, E, and F, and all the rest of the numbers. So now that we have our total, we need to find the number of ways that actually works. So I guess that in order for this to work, we're going to have one of the A's match up to one of the 1's and one of the other A's matching up to any other number that is not a 1. Now, for this to happen, we can see that there should be, let's considering that this is the first A that we get to choose, it has 2 options of 1's, this one or that one. So I'll write working here to show that this is the number of ways that actually work. It should start with 2 times a certain number. As I said before, for the first A, we have 2 different ones to choose. Now, for the second A, we cannot choose another one, and so we are left with the 6 other numbers, which means that the total working number of ways is 2 times 6, or 12. And the total here, I'll go back to here, is 8 choose 2 minus 1, which is going to be equal to 28 minus 1, or 27. So the probability should be the working number of ways divided by the total, or 12 over 27. Now, because we need P and Q to be relatively prime positive integers, we're going to have to simplify this into 4 over 9. So the answer to this problem is quite simple, actually. It is 4 plus 9. Or 13. Thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye!